In this video, we're going to continue our work with probability and look at some exam style questions. We're told an experiment consists of selecting a ball from a bag and spinning a coin. The bag contains 5 red balls and 7 blue balls. A ball is selected at random from the bag, its colour is noted, and then the ball is returned to the bag. When a red ball is selected, a biased coin with probability 2/3 of landing heads is spun. When a blue ball is selected, a fair coin is spun. In part A, we're asked to complete the tree diagram below to show the possible outcomes and associated probabilities. The question carries 2 marks. So we've got 5 red balls and 7 blue balls, so 12 in total. So the probability of a red will be 5/12. The probability of a blue will be 7/12. If we now pick the red ball, the probability of landing on a head is 2/3. So we'll have 2/3 here. All probabilities must sum to give 1, so this will be 1/3. If we pick a blue ball, we have a fair coin. Probability of a head is 1/2. Probability of a tail will be 1/2. So that's the first 2 marks completed. We're now told Shivani selects a ball and spins the appropriate coin. In part B, we need to find the probability that she obtains a head. The question carries 2 marks. So we can simply follow now the tree diagram from here. So we're looking at red and head, or we're looking at blue and head. So all I'm going to do is work out those probabilities and then we're going to add them. So we'll start now and I'll write this out. We're going to have the probability of red and a head, or the probability now of blue and a head. So we're going to have now 5/12, so we've got 5/12 multiplying up, and then we can have 2/3. We're going to add to that now 7/12 and multiplied by 1/2. So if I just go ahead and calculate this, all I've done is red and head, and then I've done blue and head. So I can write this as 10/36, and I'm going to add to that now 7/24. You can of course simplify these fractions. I'm going to leave them like so as it's going to get messy anyway, and we're just going to give our answer as a fraction. You can give your answers as decimals. I like to give them as fractions, but it's entirely up to you. So we've got now 7/24. So that's going to give me 41/72, and that is my answer. So 41/72 is the answer to part B. It says, given that Tom selected a ball at random and obtained a head when he spun the appropriate coin, find the probability that Tom selected a red ball. So part C carries 3 marks. So what we're looking at here is the probability that he had a red ball given that he had the heads. So we can write this as the probability of red and a head divided by the probability of a head. We already have both these probabilities. So the probability of a red and a head as an unsimplified fraction is going to be 10/36, which we found in the first part. And then we're going to divide this by the probability of a head, which we found in the part B of the question, which is going to give me 41/72. I can rewrite this now. Instead of 10/36, I could write that as 20/72. So my probability would be 20/41. I've just simply used the information that we had before. It says Shivani and Tom each repeat the experiment. In part D for 3 marks, we're asked to find the probability that the colour of the ball Shivani selects is the same as the colour of the ball Tom selects. We don't need to, but if you wanted, you could draw a tree diagram. All I'm going to look at now is the probability of red and red, or the probability of blue and blue. I'm not going to use the tree diagram up here. As stated, if you want, you could do. So the probability of red and red, and just writing this out, in fact we'll just write here, is going to be 5/12 multiplied by 5/12, or if you like, 5/12 squared, plus now 7/12 multiplied by 7/12. That's going to give me 25/144 plus 49/144. So that gives me 74/144, and we could write this now. If I half that, what's that going to be? 37 over 72. So as an exact fraction, 37 over 72. Let's just check that I've done that right. So 25 plus a 49, so plus a 49, and I'm going to divide that by 144, and that's 37 over 72. As stated with that one, you might, if you want, to do a tree diagram, because the wordiness of this question is not very, very kind, especially given that it has no bearing on the first tree diagram that we've done. All I'm going to put on here, let's put these on, 2 different events, and we'll have now Shivani, so let's put Shivani, and then we'll have Tom. So we can have red or blue, we can have red or blue. So red, blue, like so. These, of course, are independent events. 5 over 12, 7 over 12, 5 over 12, 7 over 12, and then we've got 5 over 12 and 7 over 12. So all I've considered now is simply using basic probability, going up here, red, and we're going to have red, or we're going to come down here and it's going to be now blue and blue. So that's what we've done here, just calculated them up. I wouldn't expect a tree diagram to be used for that part, but it's perfectly fine if you did. So as we can see, a typical exam style question for 10 marks. In the next one, we're told that a Venn diagram below shows the number of students in a class who read any of 3 popular magazines, A, B and C. One of these students is selected at random. In part A, for 2 marks, we need to show that the probability that a student reads more than 1 magazine is 1 over 6. If we look at more than 1 magazine, that's going to be A and B or B and C. So I can write that this is going to be the probability of A and B, or now the probability of B and C. I doubt we'll be expected to do that now for the 2 marks, but we can simply add these 2 intersections. There are no students here who read magazine A and C. As we can see, they're mutually exclusive, so we'd simply write 2 plus 3 divided by all of these values right here. So we've got 10 plus the 4 plus the 2 plus the 5 plus 3 plus 6. So what's that going to give me? That's going to give me 5 in the numerator, and we can see now this does sum to give 30, 5 over 30, which is 1 over 6 as required. In part B for 2 marks, we need to find the probability that the student reads A or B or both. So all we're doing is looking at this ellipse and this ellipse. So I'm going to put 4 plus the 2 plus the 5 plus the 3, and we're going to divide that by the total number of students, which is 30. So that gives me 14 over 30, which if we wanted, we could write as 7/15, dividing numerator and denominator by 2. I've simply added them up and divided by now the sum of the students. We're asked to write down for 1 mark the probability that a student reads both A and C. We can see there's no intersection. We can say now that A and C are mutually exclusive, so the answer is going to be C. So just jotting this in, don't need to write that. I'm just going to put it here anyway, just to show that I know the examiner why it's 0. It says, given that the student reads at least one of the magazines, in part D for 2 marks, find the probability that the student reads C. We can do this purely from the Venn diagram, or you can use the formula. For 2 marks, I'd be tempted to do the Venn diagram, but we're looking now at the probability of C given that they read at least 1 magazine. So let's look at that, what we have here. We've got that information from the first parts of the question, and we can simply calculate this from here. We can see now that we have 9 on here. 9 read C, so we can put 9, so that's going to be 9 out of the 30, and then we're going to divide that now by 20 out of 30. We see that there are 20 students who are going to be reading at least 1 magazine. So this is reading at least 1 magazine and C, and then we're going to divide that, which is going to give us now 9 over 20. So that's one way we can do it. So what we're saying now is the following. These 2 added, divided now by the total number in the ellipses. The numerators will simply be your answer, the denominators will cancel. So our part's done. In part E for 3 marks, we need to determine whether or not Reading Magazine B and Reading Magazine C are statistically independent. A couple of different ways. So if independent, I'm going to write this here. The probability of B and C will be equal to the probability of B multiplied by the probability of C. So we can write now the probability of the intersection, which we've got up here, is going to be now the 3 out of 30. So 3 out of 30, and we can write that as 1 over 10. If we now look at the probability of B multiplied by the probability of C, we can say that this is going to be the probability of B. Well, if we look at B, we have a total of 10 out of the 30. That's B. So we can write 10 out of 30 multiplied now by the probability of C. Well, we obtained that from before, and that was going to be 9 out of 30. So let's just write this here. So 9 out of 30. Simplifying, we can write this as 1 over 3 multiplied now by 3 over 10. The 3's are going to cancel, which is going to give us 1 over 10. Therefore, this is equal to this one, and we can say, therefore, yes, these are independent. So B and C are independent. So we'll get now one final mark for writing a conclusion. So don't just show the mouse, just finish off with your conclusion right there. We could have looked at the probability of B given C. I prefer to go for this particular approach and simply write this out. If independent, the probability of B and C now is the probability of B multiplied by the probability of C, as we've seen in previous videos. So 10 marks in total for that question. Okay, the next one, it says there are 180 students at a college following a general course in computing. Students on this course can choose to take up to 3 extra options. So we've got 112 take system support, 70 take developing software, 81 take networking, 35 take developing software and system support, 28 take networking and developing software, 40 take system support and networking, 4 take all 3 extra options. In part A for 5 marks, we need to draw a Venn diagram to represent this information. So let's go ahead and do that, and we can just put our Venn diagram like so. I'm going to have 3 different ellipses, so we'll put on the 3 different ellipses and start filling out the information. So just popping these on, we'll put one just there, and then we will put another one just here. So let's put that one just there, and that will give us what we're looking for. I'm going to label these up, and these are going to be the events, and I'll say that this one is going to be S, this one is going to be D, and this is going to be N. So S, D, and N. Let's start now with the last piece of information. We've got 4 that take all 3 options, so they are going in the middle. 40 take system support and networking. Well, we already have 4 here, so in this part we must have 36. So all I'm going to do at this stage is say now 40 minus the 4 is equal to 36. With a 5 mark question, I would expect you'll need to show some calculations. 28 take networking and developing software. Well, networking and developing software is here. 4 are already here, so the other 24 will be there. And we can say now 28 minus 24 is equal to the 4. Minus the 4 is equal to 24. 35 take developing software and system support. Well, this is going to be here, so we're left now with 31. So 35 take the 4 is going to give us the 31. 81 take networking. So if I look here, I've got 60 and then I've got another 4. So adding these together, that's 64. So this one is going to be 17. Again, I would show that calculation here to ensure I was getting the 5 marks. 70 take developing software. So if we look, we've got a total here of 35, and then we've got 24, which is 59. So we're going to have 11 here. 112 take system support. So we've got 36, 40. We've got 71. So this is going to be 41. We need to complete this by adding the students that don't do any of the 3 extra options. So adding these up, 41, 31, 11, 24, then we're going to have 4, 36 and 17. That's going to leave me 164. So on the outside we must have now 16. That is going to be the 180 minus all of the others added up, which is 164, and that will give me 16. So that part's done. Okay, a student from the course is chosen at random. We're asked to find the probability that this student takes B for 1 mark, none of the 3 extra options. We have 16 students of the 180, and we can simplify this, if we like, to 4 over 45. Often students just write down 16, but remember, we're looking at a probability. We're asked for a probability, not how many don't do any of the 3 extra options. Networking only, 17 out of the 180. So if we look now at the next part, it says students who want to become technicians take system support and networking. Given that a randomly chosen student wants to be a technician, in part D for 2 marks, find the probability that this student takes all 3 options. So we can write the probability of all 3, given now that they do the system support and networking. You can of course use this particular formula, or you can simply go ahead and look at the Venn diagram. So from the Venn diagram, or from the information, we could write this now simply as 4 over the 180 divided now by the 40 over 180. I'm either taking that from the Venn diagram, which we can see just here, or we can take it from the information here. 4 out of 180 take all 4, 40 do the system support and networking. So that's going to give me 4 over 40, which will simplify to 1 over 10. So 1 over 10 is the final answer. You can of course use the full version of this one, but hopefully you can see either from a Venn diagram or from the information that's relatively straightforward to answer. Okay, the next one. On a randomly chosen day, the probability that Bill travels to school by car, by bicycle or on foot is 1/2, 1/6 and 1/3 respectively. The probability of being late when using these methods of travel is 1/5, 2/5 and 1/10 respectively. In part A for 3 marks, we need to draw a tree diagram to represent this information. Okay, let's go ahead and do that. So what we'll do is the following. We will have now the 3 branches. So putting these on, we'll have something that looks like this. So this is going to be now the method of travel. And then what we're going to have on the next part, and I'll just put this on, late or not late. So we'll put these like so. So just jotting this down, 3 marks in total for this part, and we'll do that. So what I'll have is the first event, and that will be now the method of transport. So this is going to be transport, and then the second event is going to be late or not late. So we've got car, we've got bicycle, and we've got foot. We can have late and not late, late and not late, and then late and not late. So let's go ahead and put the probabilities on. The probability of travelling to school by car is 1/2. The probability of going by bike is 1/6, and the probability of foot is 1/3. If we now look at late and not late, this is going to be 1/5. These must sum to give 1, so this will be 4/5. If we look at the next one, we've got 2/5, so this is going to be 3/5. We've got 1/10, and we've got 9/10. All probabilities must sum to give 1, and he's either late or he's not late. So 3 marks out. I would make it bigger if I was doing a real exam, but I think I'm going to use some of the information just here. Okay, in part B, the first part, Bill travels by foot and is late. So we're looking at the probability of foot and late. We simply need to go ahead and follow that route. So foot and late will be 1/3 multiplied by 1 over 10, which is going to give me 1 over 30. So nice and straightforward for that part right here. On the next one, we need to find the probability Bill is not late. So if we look at that, we can say now the probability of car and not late, or, just jotting it down, the probability of bicycle and not late. Then we can do the next one, the probability now of foot and not late. So if we work these out, we're going to multiply them. So car and not late, we've got 1/2 multiplied by 4/5. If I look at that now, that's going to give me on here 2/5. Then I'm going to add to that bicycle and not late. So we've got 1/6 multiplied by 3/5. That's going to give me now on here 1/10. So let's just write that in, 1/10. And then I'm going to add to that now foot and not late. 1/3 multiplied by 9/10, which is going to give me now 3/10. Let's write that in. So that's going to be 3/10, and we can add these together. So 2/5 plus 1/10 plus now 3/10. That's going to give me now in total what we're going to have here. Let's just write this out. 8/10. Just going to put that as tenths. So that's going to be 8/10, which we can write now as 4/5, or if you like 0.8. Entirely up to you. I certainly wouldn't work with decimals given we've got a third, but if you want to write your answer as a decimal, you can do. That looks pretty good. Okay, let's now move on to part C for 4 marks. Given that Bill is late, find the probability that he did not travel by foot. So we can write this now, the probability that he didn't travel by foot given he was late. So let's go ahead and write this out. This now is the probability that he was now not on foot and he was late divided by the probability that he was late. So let's go ahead and just calculate this. The first thing I'm going to spot now is that I can write the denominator as 1 minus the previous answer. We've just worked out that he is not late. So that's going to be 1 minus the 4/5. And then we're going to look at him not going on foot and being late. So we need to find that, not being on foot and late. We're going to have now the following. So not being on foot is going to be for 1/2. So let's just write this out. 1/2 multiplied now by the 1/5 just here. So all I'm doing is simply putting these in, and then we're going to add to that now. So he went on the bicycle, which is going to be 1/6. So putting this in, 1/6 multiplied now by the 2/5. So all I've done in this particular case, let's just, hopefully I can show that. So what we're looking at is that he didn't go on foot and he was late. Well, that is going to be the C and now the L. Or we've got the other one, which is going to be that he went on bicycle and he was late. So that's what these two calculations are. It's car and late plus bicycle and late. So let's go ahead and do that. And of course, all I've needed to do on the last bit is simply use my answer from this part right here. So we've got now 1/10. So let's write this 1/10 plus, and then that's going to give me 2/30 or 1/15. So 1/15, and then that's going to be now over 1/5. So 1/5. I'll put that for a calculator rather than trying to do it in my head. 0.1 plus now 1/15, and then we'll check this. 1/15, and I'm going to divide that by 0.2. That's going to give me 5/6. So 5/6, and that gives me my final answer. So I've used some of the information from before. I've looked at the tree diagrams and gone ahead and solved. So 11 marks in total for that question. So there we go, a few different questions on probability from exams. Hopefully it's given you a good understanding of the different methods or techniques that you could use to solve.